I've written something, but I'm not sure because looking good. Good morning. On the 4 a.m. I was thinking about the title. It came and then went up. This evening, one of the seven I wanted to start it was one was. I did breakfast, everything is okay. Yes. Today I had
Good morning, everybody.
Good morning, sir.
Yes. Okay. It's on now? Yeah, it is. Good morning, everybody. Another wonderful morning here in Mysuru, Karnataka, India, globe, Earth. So what I plan to do, what I have in mind, and is basically what's in the brochure, the methodology part of what comes before data collection. Okay. So as I said again earlier, please don't treat this as a methodology class, because I don't go deeply into the techniques. That's not the, but I touch on them and also try to relate them to the overall process. So yesterday we finished up with a lot of aspects that are part of the methodology. Okay. Basically, I have tried to teach methodology over the years. Students come to a methodology class totally mystified. Oh, this is methodology, and some of them have these defense shields up. They have a wrong perception of methodology, and nobody has bothered to, clear them of the misconceptions. Part of the reason also, I feel, and I'm only speaking from my personal experience, the teachers who teach these subjects, they make it so dry, so uninteresting. And my first degree that I got in India was a BSc in mathematics, physics, and chemistry. That's my origin. So I have been dipped 16 times, as they say, in the natural sciences, And if I criticize them, it is not out of ignorance or hostility, but anyway, we talked about that. So anyway, the mathematics, all of them, the physics teachers, they were so dry. They made the subject so uninteresting. In fact, our mathematics teachers, I went to Loyola College in Vijayawada. This man wouldn't even bring a textbook with him. He would just come into class and say, open page 162, rider number 4. The man has no book in his hand, but he has the book right there. No interaction. I mean, it was a different time. I don't know if you guys are if university teaching has, changed. So coming back to this whole thing, so when I started teaching methodology in the United States, almost 36, 37 years ago, at the undergraduate level, this was a challenge. And it took me a few years. It took me about 4 or 5 years of teaching it, 2 semesters every academic year. Certain light bulbs started going on in my mind. One was, why am I teaching why am I teaching methodology to these kids? Okay. Are they going to become methodology specialists? How many of them are going to even go to post-graduation, let alone PhD? and the number is very, very small. So I have to make this class interesting and relevant for the people who are taking it. Otherwise, they're all going to sleep. I don't want to be like my mathematics teacher, right? And so I started demystifying. You know, there's nothing mystifying about research, nothing. It's simple. But if it's taught that way, with examples, then it starts making a lot of sense. And one anecdotal thing that I have always used is comparing doing research with constructing a building. Everything that goes into constructing a structure, building, how it's the same process. You begin, you survey it, and then you come up with a blueprint. That is their methodology. Blueprint. That's it. And so we don't work with bricks. We don't work with concrete, steel, but we work with ideas. We work with concepts, social concepts. Okay. And that's how we have moved. So move on, you know. It's a deductive process. I think we went over this in an earlier session where the early part is a deductive process. So it is deductive the whole time. From theory, you have come up with questions or hypotheses, and then from a general definition of your terms, you're coming up with a firmer definition. And from that, you're going to get into specific operational definition that you're going to be using in your study. Everything is so deliberate. Everything so that, because the task is, we are still following the natural science, physical science model. We assume that there is only one reality and it's outside us. That assumption is still there. So how to make all the people in this enterprise see that one reality, right? So if I ask somebody in US 20 years ago in front of a grocery store, go inside to the fruit section and bring me a mango, you get only one chance. I want everybody to bring me a mango. I want them to go to the fruit section and look at all the fruits and say, aha, mango. How good is my operational definition so that they will land on a mango the first time? Same thing. Instead of mangoes, we have ideas and concepts, violence, media violence, exposure to media violence. Okay, violence. So we can start with violence in a general way. You all know what violence is. But then soon enough, we'll say, sir, there is physical violence, there is emotional violence, there is verbal violence, and somebody will say, sir, there is also spiritual violence, sir. Okay, whatever, throw it in. Okay, then we say, all right, for our study, we are only going to look at physical violence. Okay, that's fine. You could do verbal violence if you wanted. Remember, it has to be physical and or verbal. Because remember from yesterday, every one of our variables, we should be able to collect data. So something that is explicitly said or shown, data can be collected rather than, you know, I'm giving you the killer looks, like, you know, I'm going to kill you. But how do you decipher that? We we leave them alone. So we don't go with latent aspects. We go with what is concrete. Okay, so where was I going? They have to see the same. So operational definitions have to be exact. And you train, you don't get it right the first time. So you train people with training so that the agreement rate of what they're seeing, something that you're doing, is at least 8 out of 10, 80%. 80% is a threshold that we try to, the intercoder agreement should be 0.8 or higher, maybe 0.75 and higher. 8 out of 10 times they are seeing the same thing on the screen. George Gerbner did content analysis. So before I go on then to content analysis, okay, so from operational definitions now, we need to make sure that it is a variable. That is, we can collect data. So we break it down so, so that we can go out and collect data on that. So it must be empirically possible. And then what else did we do yesterday? Yeah, it stops there. But there are several aspects about this I talked yesterday, and I'll be talking again today under this measurement, another area that overlaps this measurement, because we have to, in the methodology, decide on a few other things. Now that we know our elements, concepts, definitions, operational definitions, research questions, that's how you ask, hypothesis, if you can, they will have independent, dependent variables. What are they? Define them, operationally define them, all of that stuff. And so we are train your people who are going to do administer questionnaires, interviews for you, or in the case of content analysis, people who do the coding for you, okay, train them. But there are a few overlapping issues, which I definitely have talked about, but not gone deep enough. That is what we are going to be doing today, measurement. Actually, everything we've been doing until now is also measurement, or rather we are going to facilitate measurement or proper measurement so that we can collect data. And before going on to that, I just wanted to touch on something that you probably know very well. Depending on what we want to do, research questions, hypotheses, we will select from certain available research frameworks. The ones that we use commonly are the survey. Survey can be of many types, but still there's a survey. These days, online surveys have become very popular. Once upon a time, and even today, surveys were mailed through the postal service or on a paper and pencil. These days there's a lot of questionnaires, surveys being done online. All right. Another framework is content analysis, which is done a lot by journalism and communication people. This is an analysis of message content recorded on any medium, available and accessible. Newspapers, audio, video, diaries, speeches, anything that's recorded. So if your study is about comparing or looking into content of some medium, any medium, that is what you would have to do. do a content analysis. Experiment is yet another one. It's done, not very often. You have to set up experimental conditions, experiment and no treatment and no treatment, and how do you select people for your experiment? And selection of people involves survey also. You have to select people. Experiment, you have to select people. And so we'll talk about sampling today. Experiments it's a much smaller number. Each group might have 20 people at the most. It's a small number, but still involves some aspects of sampling. How are people selected and distributed into the two groups that we call experimental group and control group, okay? So when I do sampling, I will talk about that. And so basically, in an experiment, you have a pre-test. That is, before you introduce your treatment, you take a survey of what they. So for example, your study is about, no, that's more, okay. So do excessive exposure in terms of number of hours per average per week to violent media content cause, and I'm using the word cause deliberately here, cause physically aggressive, increased physical aggressive behavior. Okay, let's just go with that. Let's not worry about, is this a great hypothesis or not? Just for the example. So obviously, the treatment you're going to give is exposure to violent media content. That's the treatment. So you do a pre-test before the treatment. You give them at the very least, remember what you're after. You're after increased aggressive behavior. So you need to take a baseline mark on where their aggressive behavior is right now. So through survey questionnaires, interviews, whatever, you get that from each participant, both in the control as well as in the experimental group. So you will get, in this particular case, an aggression score going from low to high for each person and each group. You have that information. Then the experimental group would be subjected to, X number of hours of continuous, mayhem and violent kind of media. There are plenty of them around these days, okay? Just to take a commercial break here, my wife and I, back in our Bowling Green home, I don't know whether many of you know, Telugu and Tamil films are run in film theaters all over US, okay? I hope Kannada also shows up. And I live in a small town. I don't live in New York City. So Kalki was playing in a theater 40 miles from where we live. So we went and saw Kalki. And we saw the Telugu version. Of course, Amitabh Bachchan speaking Telugu is hilarious. He doesn't speak Telugu. He just goes, that's what he was doing the whole time. And of course, Telugu is coming out. Anyway, why am I talking about? Oh, Kalki, right, Kalki. Deepika Padukone is there, Oh my God. That movie was an orgy of violence. you know, buses being thrown at you, no buses at that time of thing, rocks, boulders, chariots, people's neck being turned X number of rotations. Very difficult to watch for me and my wife. Finally, after 2.5 hours, he said, okay, end. Both of us eagerly looking for the end. Then it comes, to be continued. Oh my God, that means there's another movie coming? Yeah, apparently, yes, Kalki 2. So imagine watching that for 8 hours. And that is the treatment. The control group does not watch those videos. What do? Go and play tennis or cricket? No. They will watch something else. They have to be engaged in a similar activity, but they will not watch any violent videos. So we have to provide some general videos, nature scene, lions in Africa, or deer, whatever. I'm just giving you examples. Don't make them watch kids' things, because that can also get very irritating. Same time of the day, same room, with the same colored walls, okay? Preferably by the same people who are conducting the study. And then after some time is a post-test, where you again measure the level of aggression. These are all psychological scales that you administer, and you will get a score for each person in each group and group score. Okay? You look at the difference in scores between post-test and pre-test for both groups. And look at the size of the difference, if any, in the aggression scores, right? And then you compare the two groups. You expect that if the violent videos were the cause of the change in the aggression scores, that is, when you compare the two groups, the group that got the treatment has statistically significantly higher score than the one, then you can say that it is the videos. So how do I explain any other confounding variable? Simple. I had a control group, and I have not told you how those two groups were selected. We'll talk about it. But I made sure that the two groups are very, very similar. To verify that, I also gave them a pretest. So I have objective scores. And if indeed my selection of the people into the two groups was done very well, I should see no significant difference in the aggression scores between the two groups. So that is a further verification that they are similar. And then one group gets the treatment, the other doesn't, but is treated in exactly the same way. And then you take another test after that. If there were some confounding variable that you and I do not know, the use of the control group will, because if there was some confounding variable affecting aggression other than the video, then that should have showed up in the difference in the scores between the pre-test and the post-test for the control group. Then okay, why is the control group's aggression going up? They did not even watch the video. Something is going on. you know, and there are at least 15 to 20 reasons which in a methodology class they can tell you. But for now, we can just say confounding variables. So that is the gold standard in medical trials on drugs and all that, where they have to compare. That's the methodology, okay? I mean, you can make it very specific, but basically that's the methodology. So these are the three frameworks that we deal with most of the time. And we use experiments only when we are looking for cause, because both surveys and content analysis, they provide plenty of data, but it is correlational data. If somebody does a survey and uses language implying causality, some of the words are, look for words like influence. But influence is okay, depending on how they construct the sentence. Impact, of course, cause is a total giveaway. Look for any word that somehow implies causality. No. All you surveys can show is relationship, correlationship. Okay? It's the first prerequisite for causality. But there's a number 2 and a number 3, right? Number 3 is all confounding variables. Yesterday I gave, it's in the PowerPoint from yesterday. All confounding variables have to be controlled. So content analysis and survey do not do that. Okay, so that's a little bit about the framework. So let's move on to measurement. Yeah, next please. Well, starting at the very beginning, what is measurement? Anytime we want to find empirical reference indices for our variables, so we use different ways to measure. If I were to measure your height, I will have on this wall demarcation on centimeters, meters, okay? I'll make you take off your shoe and stand against the wall, and then I will read off the score on top of your head. That's your height. So that was the measurement. You take an empirical referent of this concept called height, and you are 1 point something meters. So now we don't take interest in weights and heights, but we do collect a lot of information on people's awareness, people's attitudes, people's opinions, on many social concepts, health concepts in our surveys. Similarly, in content analysis, we look at different topics, but the measurement is still the same. We reduce our variables such that an empirical referent is available that is measured on a standard scale. Okay? So in social research, we have elaborate rules, procedures, etc., for measuring variables. Remember, this is a big deal. Until now, we have been trying to see if we can get everybody to see the same thing. Now we are looking at, can we get everybody to measure the same thing? After you see, you're going to measure it, right? You got to record it. I want to make sure that that is also done in a very systematic and precise way. So what I have there is a recap of what we have been talking about. We move from abstract concepts to conceptual definitions, then on to operational definitions. Finally, we move to observation, that is recording the data in some way. So the goal obviously is to have very clear, observable, empirically observable and verifiable reference of your terms in your hypothesis. Let me work with one example for you. Dr. George Gerbner, University of New York, I believe, he did a lot of content analysis in 1967, 1968, 1969. I mean, for several years, he did content analysis of the media in the three networks at that time in US, ABC, CBS, and NBC at that time, three networks, primetime programming, which starts around 8 p.m. and goes on till 11 p.m. prime time. So the amount of violence in the entertainment programs beamed at that time. So he did content analysis. He selected a sample of programs from all the networks, all the months, over the years, analyzed it through content analysis. And he gave us not just data, but he gave us theories. If you read mass communication theory, there are a few, like cultivation effects. That's Gerbner. And the cultivation effects he talks about came from his content analysis. So he painted for us a picture of what is available on TV during prime time. What is the world that is being shown? After all, those entertainment programs are programs about people in a certain context. What kind of a world is it? And he gave us lots and lots of information about the TV world, okay, through content analysis. Not just, of course, but I don't want to talk about all of that, but I want to talk about, he looked at the quantity of violence and the quality of violence. Under quality, he defined minor violence and major violence. Again, he had definite. So I would like to use the operational definition of that just as an example. So obviously, he was going to employ a lot of coders. Each of the coder were given several hours of the sampled videotaped material, not the same, but part of the sample. And they were asked to go what would be given sheet and to note down quantity, quality, what they see. So here, as soon as the videotape was turned on and it started rolling, you have to identify what violence is. You have to see the same thing, okay? So he operationally defined it as any overt act where two or more people are involved and where there is body contact or contact with body and an instrument with the intention to harm, hurt, kill, or destroy. Now, with that definition, he would train them. All of them would watch the same material. And remember, get a intercoder reliability score of at least 80%. And then the real study would start, and each of them coders will get hours of videotape material. But the intercoder reliability had already been established. And so it is an overt act, not something inside your mind, overt. Out, you should be able to see. Look for two people. Okay, two people. Okay, there it is. Body contact. This guy suddenly punches that other fellow. Body contact. One act of violence. Suddenly he gives another punch. Two acts of violence. And then the other guy punches. Each act is counted on the coding sheet. At some point, it will, and of course, you also look at other things. Man, woman, who is it? Who is the perpetrator? Who is the victim? You know, lots of information, but it is overt and you can see it. With the intention to harm or hurt or kill. So if two people hug each other, that body contact shouldn't be counted because there was no intention to hurt. Very explicit, so that we all see the same mango and pick it up. We're not seeing an orange instead of a mango or a pear or some other. So that's all there is to it. Surveys, we operationalize it in a different way. We prepare structured questionnaires, okay, where we break it down by all the variables in our study. How do we operationally define? We define it by, I'll show you one example. Maybe this is a good time. There is a Word file. That questionnaire. Can you please put that up? What I want to show you is a survey questionnaire that was prepared some time ago by one of my doctoral students, Dr. Fang Wong. She's an assistant professor, almost going to become associate sometime. She looked at the cases of bulimia and body dissatisfaction among university students, and to see whether social networks had any kind of an impact on that. So she measured their participation in social networks like Instagram and others, and then collected information also on body dissatisfaction, eating habits. So here is an example of a structured questionnaire. As you can see, it should be showing up on your screen. These first set of questions, I think at this point, are meant to gather information about their knowledge of food stuff, okay, which is very important for them, all right? What is not shown here, this is a questionnaire that was given or sent to the respondents. But we will have a version of the same questionnaire where we will code it, a coded questionnaire. So you will see many times a number 1 will be there, a number 2, number 3, number 4. And for other, there's no other here, other, there'll be a number 9. Just remember that when we pick up SPSS, okay? So when we get the questionnaire filled and back, we will enter the numbers that we see. That's a structured questionnaire. This is also a structured questionnaire, but it is not coded. Here you go. Keep going down, please. Yeah. Yeah, all of this 9 or 10. Please go to, yeah, stop. Up to 10 is, you can create a score for each person on the level of knowledge they have on, whatever is there. I mean, all these questions have been picked very carefully. And one thing you can remember is that it is okay to go and look up the questionnaire or any questionnaire that is publicly available. Most university studies are publicly available. It is all right to use a questionnaire developed by somebody else, as long as you give credit to that. In fact, you can get books where they have model questionnaires on, this is all technical topics like health related, and you can use them. You cannot do that for an article, use somebody, verbatim, but yeah. Now, starting number 2, notice it's already coded. This one is coded. There are numbers 1, 2, 3, 4, 5. And read the questions. And the person is supposed to either all the way from strongly disagree to that statement to strongly agree. And that person will get a score that is on top, 1, 2, 3, 4, 5. But you will also notice that some of the items are going in opposite direction. So those numbers, for example, these two are going in opposite direction. I know lots of people who eat healthy food. The next question is, I know lots of people who consume fried food. So they always state the statements in a way that is user-friendly. User-friendly, okay? If some statements are going in opposite directions, because one means, you strongly disagree on a certain scale. I'll make that clear in the next one. You can always recode it. That's not an issue. Please go down. Here, stop. This is an example of a constructed scale for motivation to eat healthy, or motivation to avoid fat at all costs. These people are extreme people, they have health issue. So this is a long questionnaire. I'm only showing you a few pages of that. Motivation, and each item you can see, stick to low fat, low sugar foods, even when I feel depressed, bored, or tensed. You go all the way from, how sure are you can do that? Definitely I could not. All the way to, definitely I could. And some of the questions are in opposite direction, For example, this says, I want motivation to stick to low fat. This one is motivation to avoid low fat. Opposite direction, right? We like to query them. We don't want to put people into a response set in a questionnaire. What is a response set? For every question, the same, you can tick off the same. Inni, mini, minor, mo, tuck, 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 tuck. No. Make them focus. Next question or 2 questions, turn it around, where they have to give an opposite answer if, So anyways, we can always recode it afterwards, and we will get, please go a little bit down. Yeah, there, stop there. 10 items. I will get an individual score for each person on that scale. So this scale goes from, each item goes from 1 through 5. 10 items. So the lowest score you can get on this scale is 10. And the highest score you can get on this scale is 50. That's the range. And all of them will lie between 10 and 50. That is your scale. Scales, this is the operationalization. Operationalization of a variable is nothing but make it so clear that the person can understand you. That's the whole idea of no ambiguity, no doubt, nothing. So the sentence is constructed, by the way, we work on these sentences for weeks together. And it has been pre-tested. And then you get this. So that when I read that question, I know exactly what that question is asking. And so does everybody else. That's the operationalization. So in surveys, the only contact you have with your respondent is that online questionnaire. Okay? Sometimes in situations, like, for example, India, I don't know how far it's true. It used to be true in the 1970s. When you start going into rural areas, literacy levels are not high enough for them to be able to read your academic questionnaire and figure it out. So many times the interviewer will read the questions. It is still a structured questionnaire, except that somebody is reading. You're not supposed to influence the answer in any way, just a neutral ask. And then what do you think? Do you think this? Okay. So that's the way. Either ways, it's a structured thing so that we are getting people understanding the same thing, and the data is also going to accurately the way it's. But there's a one question that remains here, and I'm going to pick this up, a little bit down the road. You can't just take 10 statements and put them together and say, hey, I have a scale. How reliable is this scale? For example, height, feet and inches. It goes, 12 inches make a foot. So, and that is all marked. That's the scale. It's the accuracy and the reliability and the validity of that scale is right there. Of course, this is a kind of a different scale compared to what we think. The question here we want to know is, together, you're giving me a score for each person on a particular, for example, this was motivation to eat a healthy diet. How do I know how good do all these statements are reliability? Measuring accurately in the sense that if you gave this questionnaire in the morning, they will answer in one way. If you gave the same questionnaire in the evening, they'll answer in a slightly different way. That means it's not reliable. Reliability gives you, with repeated measurements, consistently the same. That's, if you take your height, okay, and you are 5 feet 7 inches, 15 minutes later, I take your height, it should be 5 feet 7 inches, no. Suddenly you're 6 feet tall, there is some problem here, either with you. Don't eat all those protein foods, man. No, I'm just joking. Scale, reliability is consistency, stability in repeated measurements across a short duration of time. Okay, reliability. So question of reliability is, will I get on this scale similar answers? Then there's something called validity. Are these actually measuring motivation? For whatever you said, what did you say? Motivation to eat healthy. Okay. Are each one of these statements actually tapping that? That's validity. And then the next question is one statement better than the other in terms of its validity? Does one of these statements give you more information? Or all the statements are equally good? And finally, is there a bad apple? In a basket of apples, there's one bad apple. We need to remove that bad apple, right? So is there a bad apple here? Something that doesn't fit with the rest? These are questions that are analyzed for reliability and validity in scales. What you can do is you can go to a book of psychological scales and health scales and select what you want. And at the bottom, they will tell you they'll give you a quantitative number called Cronbach alpha. Cronbach is C-R-O-N-B-A-C-H. Cronbach alpha. Cronbach alpha goes from 0 to 1, just like the Pearson R. But the closer you are to 1, the better. So scales should have a Cronbach alpha, should get a Cronbach alpha score when analyzed at least 0.7, 70.7. So you can select. If a certain scale that does not exist, you may look at questionnaires used by other people and all that and pick and choose and edit them and do all of that, collect data. This is in your pretest, that is. And then run a Cronbach alpha. And you want a Cronbach alpha of at least 0.7. Then that's fine. And report it because your committee will be happy, you know. That's how we test the reliability and the validity. And I'll talk a little more about these two items in when I get down to that. Can you go down here, please? Yeah, stop. So number 4 is also coded. This, as you can see, is tapping behavior. Knowledge is one thing, behavior is, other. So this is tapping into behavior. I think this is, this study was done about 8 years ago. So please forgive me if I don't remember, though I guided this. This is a dependent variable, behavior. Yeah, and then finally, and so you'll get, this is also a scale. Finally, you have your demographic information. That's an example of a structured questionnaire. You can also have an unstructured questionnaire where you don't give prepared answers that they can take, but you leave some space for them to fill out their own answers. The only problem with, and sometimes you're forced to do that because of the nature of the subject. But the challenge with that is after data is collected, you can't enter the data immediately into the computer. You have to now go ahead, read every blessed questionnaire, read every open-ended answer, and code it according to 1, 2, 3, 4. At the end of the day, it has to be reduced to a number if you're going to be using quantitative statistics. Okay. All right. So can we go back to that PowerPoint on measurement? So having discussed this, let's get back to measurement. Yeah, the goal is to specify, and the whole idea is we are moving from the theoretical deductive to the operational, to the research phase, to the real phase, where we break down concepts to empirical reference that we can see in real life. So that is the bridge, that we have crossed over. Next one. Next. Oh, okay. Sorry. Stay there. I kind of went a little ahead of myself. And so what I was talking about earlier was how we operationalize in the different research frameworks. I already talked to you about surveys, experiments. In the case of experiments, we, the researchers, operationalize. It is done manually. We said we are looking at the exposure to violent media cause. So we will operationalize that by creating one group and exposing them to what you and I, the researchers, have found is the treatment variable. Okay. The other group, the control group, does not. By the way, what I'm giving you examples is a very simple experiment, but experiments can be complex, but I'm just giving you the general idea. And also, simulations can be done in other ways too. I told you yesterday how people are made to watch videos and, to change their moods, and then they are taken to another room where they shoot at each other with sound gun. That's another way of measuring, So experiments can do this in several different ways. Content analysis, the idea is very simple, but it'll be different to do because you're coding messages, your message coding content. So because of the different nature, it'll be different how, but basically you set up a unit of analysis. So if you're comparing two newspapers in terms of stories, then what are you going to count? So your unit of analysis, you can say, is a sentence. One sentence. What is a sentence? A bunch of text that lies between two full stops. That's a sentence. So everybody must know what a sentence is. Two stops. That's a sentence. So you read that sentence. And then categories are prepared coming out of your hypothesis. Is this a positive coverage? Is this sentence talking positively of the Prime Minister? Is this sentence talking negatively? Is this sentence neutral? Is this sentence unrelated? You'll have those categories. So each sentence will need to be coded. And you do this sentence after sentence after sentence for all the selected, maybe pages, depending on your study, or stories, depending on your study. In the case of video, the unit of analysis could be different. It could be every scene. And we will define what a scene is. Most people know what a scene is, but you'll define. This is a scene. So when you watch each scene, look at it. How much of violence was this in this scene? Scene 1, scene 2. Some other people say, choose the characters on the video and just report what you see. And they say anybody with a speaking part is part of your study. So when you roll the video on your violence video, you're looking at scenes, but which one should I select? Any character, anybody on the screen who opens his or her mouth at least once. If I say, hello, I have a speaking part, right? And then note down, male, female, white, black, Asian, and then you can count aggression, whatever that definition is. You can do all of that for that character. And obviously you have to do that for all speaking characters. So you set up this explicitly It could be a sentence, and depending on other media, it's the same thing. You have to set it up, and then coders will collect the data. The analysis will be very similar to a survey. We haven't come to that yet, but yesterday we did analysis with Pearson R and chi-square. Next, please. So this is something that I talked about in the passing, and I definitely know that you know this. And so just all the way to the bottom. Yeah, that's it. It is possible to classify all our variables into these four. What is important about this is that as you go down this list, it makes it possible for you to use high-level statistics. Parametric statistics may only be used on ratio level variables, okay? Nominal is just label, category. Male, female is a label, okay? BJP, Congress, label, okay? So there are many labels. We still have to give them numbers 1 and 2 and 3 because we have to code them, right? But those numbers have no meaning in nominal variables. They are just done so that we can do the analysis, okay? Male is 1, female is 2. Or female is 1, male is 2. It makes no difference. It's a nominal variable. But when you start getting into ordinal, the number makes a difference. Ordinal is anything bigger, anything smaller, anything harder, anything softer. It's on some intensity scale. And so you group. You take people's height. You have an individual score. What if you didn't want to do that? What if you wanted to bunch them up, people between these heights? So we do this for income groups all the time. People earn income in exact money, right? But a lot of the times for the income variable, we always put them in. We don't say, we say income, 40,000 to 60,000 per year. 60,000 or whatever the next thing to another one. These are groups. So anyone who falls in a certain group, they're counted. But the groups are ranked as 1, 2, 3, 4. We know that group 2 has a higher income than group 1, and group 3 has a higher income than group 2 and group 1. That's ordinal for you. Rank order on some scale. Interval, we have very few examples of interval because ordinal doesn't tell you the distance between the scales. Is the distance between one and second group exactly same as the distance between the second group and the third group? Ordinal, I cannot answer that question. I can only tell you this is higher, this is lower. Interval goes one step further and says, hey, I can also tell you the distance between the scale, and by the way, they're exactly the same. And one good example we have is time. Or in even height. The difference between two markers on the height scale is the same distance between two similar markers on the scale. Same with time. Distance between 10 minutes and 15 minutes is the same between 15 minutes and 20 minutes, 5 minutes each. Equal interval scale. But instead of grouping, just imagine, instead of grouping income, what if we asked in our questionnaire the exact, how much do you make? I mean, we don't ask, but this is just for the example. How much do you make? And somebody gives you the exact number, let us say. Now we have ratio level variable, right? Not only can I say this is higher than that, but I can answer a very important question. By how much? So you can make ratio level statements, all right, based on that. And that would be nice. But then you can't force it. It has to be naturally possible to get that kind of a score. We create scales, and this is a question I have not been able to answer, when my students have asked me, but it's a common practice. Even though the scale that I showed you in that questionnaire was ordinal. Okay? Strongly agree, neutral, disagree. You know what way it's going, but I can't tell you between each category that is the distance the same. It's ordinal. But I have found, and I have tried to look at research that is published everywhere. When you collapse all the answers to the question and create a score, you get an individual score for each person between the minimum score 10, maximum 50. And then we use ratio level statistics on it. I guess that's allowed. Even though you started out as ordinal and then ended up getting a single number, which you can then compare ratio level. So that's apparently allowed, and you can go ahead and use that in the analysis. So yeah, anytime you cannot, if both variables are at the nominal level, you have to resort to non-parametric statistics. Chi-square is one example, of that. Okay, let's talk. Let's talk a little bit about error. Measurement error. In reality, or when you measure anything, let's confine to research. When you measure anything, you are not getting the true, quote unquote, the true value of that. There's always error in research. Some errors you just can't help it. It's called random error. It just happened. It just happened. What can you do? Next time you do that, that same error won't happen. It's a random error. Example, you're taking a test. Okay? And on that particular day, you're not well. You have this blasting headache. Okay? So, you're not able to do well on the test. That's a random error. So there are a few people who, don't do well but next time you may not have that situation. So random errors occur, but random errors, according to the law of probability, occur in both negative and positive directions. They cancel themselves out, random errors. So don't worry about them. If just 1 or 2 or a small percentage, there's a problem, it's a random error. And if the error is in a positive direction, it can also be, that same error can be in the other direction. But then there is something called systematic error. This is the one that we have to tackle in our research protocol. The word, it tells you exactly, it is a systematic error. That means that there is a concrete bias. And what this will do, the systematic error will do, is that it will bias the data that you collect. All right. Let's take the same example this headache example. Let's forget about headache. The measurement, the testing is done in this auditorium that we're all sitting here. The place is, the air conditioner is not working. It is summer. The place is hot. Okay. And obviously, everybody is suffering from the same thing. It may impact your performance. Tomorrow, when you come to take another test, AC doesn't work again. This is a systematic error. It's not random. Systematic error. There is some problem somewhere. The systematic is nothing but the tendency for a long-term bias in the result. The results lean in one direction all the time, low or high. That's a systematic error. And so we have to control for systematic error when we do that. Here are some examples. Again, I would request you to please read a methodology book that systematically, all the time that is, influence your measurement in a particular direction. For example, students who aspire to go to United States for higher study, they all take the GRE score test, or the GMAT if they want to go into business, GRE scores. For a long time, there was an argument. You know, I have served as an administrator in academic institution for at least 10 years, you know. And so I had to deal with all these GRE scores. There's a lot of criticism of GRE scores, even within United States. Black students and minority students say the questions are biased against us, okay? They choose a paragraph and ask you to analyze it and all that, but that thing is tailored for a certain audience. So if you are not part of that audience, for example, when I took the GRE score, I had to read a paragraph, or maybe it was TOEFL. I had to read a paragraph and answer a bunch of questions. And in that paragraph, it was, she's talking to a guy, young woman, and her cheeks turned pink. Okay? And then go on. And then one question, was she embarrassed? I don't know. Her cheeks turned pink, man. That is a cultural word that the woman is embarrassed. Hey, but I don't live among white people. I live in India. People's cheeks don't turn pink here. So anybody like me will answer that question wrong. It's a systematic bias. See, get an example. What are some of the other ones? Reactive measurement effect. This is a huge problem in surveys. People are people. When a stranger comes and asks them questions, just the fact that somebody is interviewing you, is in front of you, talking to you, will make you change your answers or be on your guard. It's called reactive reaction. It's called the Hawthorne effect. There was a factory in the state of New York that was manufacturing something, and every once in a while, a bunch of inspectors would walk through the factory floor, and they found that every time this happened, the productivity of the workers went up. They were reacting to the presence of these people. Oh, wait, somebody's watching us. Let's work faster. Let's work, That is a problem. And we have to deal with that, and there are ways to deal with that. Social desirability effect, that's another systematic. You know, when strangers come and talk to you or ask you questions, you're not going to be frank like with your best friend. You're going to say what is socially acceptable. Let's say there is, just as an example, let's say there is a questionnaire where you're being asked on a lot of political questions in India. And there are some that, you would like to be critical of the ruling party. But are you going to be critical? Oh, yeah, everything is okay. Everything okay. Yeah. All right. Yeah. So we're going to stop after the next one, and then we'll continue after the break. Acquiescence response effect. There's another thing. It's funny. People like to not only say things that on controversial topics that are not controversial. For example, do you support homosexuality? This question. You are going to look at the society around you. You're in Mysore, right? Oh, no. I don't support homosexuality. But actually, you don't care. Hey, if somebody does something on their own, that's fine, yeah. But that is social desirability effect. And there are examples of that. Hope if you remind me, I can give you in the second half. Acquiescence is people want to agree with you. They don't want to pick up a fight with you. You know, yeah. That's acquiescence response. These are all things. So we have to frame our questions in surveys expecting this to happen and change, ask the same question in a different way later on. You know, you can lie once, but you cannot lie all the time. That's the human thing, right? You can catch them. So anyway, these are all that you should be. So let's go ahead and take a short break, and we will be back. Thank you. Okay, let's get started now. So moving along then, I have been talking a lot about reliability. And so here are some examples of reliability. Basically, it's having measuring instruments, questionnaires, etc., that give you stable answers across repeated measurements over a short term. That means there's consistency, there's stability. Now, when you get stable readings or measurements across measurement of the same thing, it also gives you a good idea that random errors, or rather random error is low, because you'll see right away there that if you're not getting with repeated measurements a consistently same, then you're expecting the same, could be random errors. So that takes, take care of that. How do we measure stability? There are many tests. There's one called the test and the retest method. These are all done before you have your final instruments ready for data collection. If you're testing the proofreading ability, in a newspaper office, proofreading scores, how good you are. So, or rather, no. Let me take. You're measuring some, attitude through a questionnaire. I showed you a questionnaire, and you're getting scores. All right. You repeat this exactly the same thing to the same group again. You expect the scores that you got on the second to be about the same. Test, retest, compare the two, compute Pearson R. If you get a correlation of at least 0.8 or 80%, that's good. So you're testing for that. Next, please. We were talking about the scale, items in the scale, how to test reliability of a scale. I made some comments, and so probably it's a good time to go a little deeper into that. So I showed you a scale with 10 items. And I said these 10 items will be computed, collapsed, and you'll get a single score on that particular scale for each person. The scale has been tested, and it has a Cronbach alpha of at least 0.7. Now I'm collecting data from that. So one of the tests for reliability is each item the measurement that you're getting, are they pulling in the same amount of reliability? So one way to do that is take those 10 items, randomly divide them after you've collected the data, randomly divide into two halves, 5 each. So instead of 10 items now, you have 5 items. Compute the score for the 5 items. Compute the score for the other 5 items. If they are equally reliable, then the two score on the 2 random halves should be about the same or very, very similar. So you run a test. Then that means that when you randomly split it and measure, they both are measuring in the reliable in the same ballpark reliability. You can run reliability in another way. Do we have a bad apple here? Do we have one statement in the scale that shouldn't be there? It's, we can do that also by looking at correlation between a single item, what somebody answered, with the composite on the other 9 items. So take the person score just for item 1, and then take the average for the next 9 items, compare the two. You expect the correlation to be high, at least 0.5, 0.6. But if there is no correlation, close to 0 or very low, that means that this item is not contributing, is not going along. And you do this for every one of them, 1 with the rest 9, 2 with the rest 9, 3 with the rest 9. That is called inter-item correlation. Alpha test is more comprehensive. I told you about Cronbach alpha, average of inter-item correlation. So I take one item in the scale and correlate it with the composite score on the other 9 items. And I do this for every item, and I compare the 10 scores, and I expect, look at the average, and I expect it to have a Cronbach alpha of at least 0.7. So I did item to total, that is 1 against all the others. Okay. Actually, in SPSS, as I told you earlier, there was a time when we had to do a lot of these things by hand. But now it is as simple as knowing how to run a reliability analysis. It's just one command. And SPSS, before you can say hello, SPSS will have a output ready for you. And then they will, and you're looking for these points. What is the Cronbach alpha for item to total? What is the Cronbach alpha for, average? What is the Pearson R for, between items? All of this information will be there. And you want to make sure you're doing yourself a service by weeding out some bad apples, because they are hurting you. This thing about inter-coder reliability that we do in content analysis, where all the coders who are helping you with your analysis and looking at content, they're all coding in a similar way. It's the same thing, inter-coder reliability. You train them and make sure that, you get a high correlation. And when you're training them, they are looking at the same thing. They're coding the same story. Then obviously you expect them to code the same way according to what you have instructed them. So that is called intercoder reliability. Next one, please. Here are some ways, that you can improve reliability. Some of this, arises from sloppy work. Some others are a little more than sloppy. It tends to be systematic, and you have to be aware of that. Preliminary tests, pre-test everything. Okay, and so if something is sloppy and not working, they'll all show up in pre-tests. And simple things, talk clearly. Give clear instructions in your questionnaire, how to answer and what to answer. Make it clear so that everybody is at the same place when they start. I have talked about the others. High reliability is necessary, but not sufficient. because you can be reliably wrong. Right? So there are people who just don't know what the heck is going on, but they all agree. Very reliable. So validity, next one, is another thing that we look at. Next one. Validity is nothing but, are you measuring what you're supposed to measure? That is very simple, One way is, two of them are very subjective. Just look at what your question is and see if that makes sense to you. That's face validity. Okay. And so, for example, this is my famous example. You're hiring secretaries in your office, and basically you want to know how fast they can keyboard. And so 10 people apply, and you say, okay, tomorrow we are going to have a test. Yeah, what is the test? Can you all come by 8 o'clock in the morning, please? And please make sure you all wear running shoes. Running shoes? Yeah, let's wear your running shoes. So they all show up at 8 o'clock, and you make them run 100 meters. Whoever comes first will get the job. Why? Because she's a fast runner. But are you hiring runners, or are you hiring typists or keyboard? So on the face of it, it doesn't make sense. That's an example. So you could read the item in your questionnaire and say, wait a minute, I thought this was motivation for good diet, but look at this question. How often do you work out? What has that got to do with diet? I'm just giving you an example. So some things you can just look at it, face validity. Content validity is very similar. Read the content and say, is this what I want? Yeah, that's what. So it's very simple. But objective indicators, okay, there are objective indicators for validity. Something called criterion-related validity. Okay, this is an example I have used quite a few times. You're doing a survey on people's knowledge and people's attitudes towards abortion. Okay, that is your study. And so you will have questions, you'll have scales to find out the intensity of attitude towards or against abortion. And you want face validity. You want to make sure that every item in that scale is measuring something related to abortion. Of course, you can look at it and say, yeah, that question seems quite obvious, doesn't it? But let's go beyond that to objective. Now, what you're going to do is, there are two associations in your town. One association is pro-life. Pro-life. These people are very strong against abortion. Pro-life. They want, and this is known. They're all members of this organization, and you have read in your papers about how this organization has staged events and protests and blah, blah, blah. You know that, members. There's another organization or a group of people, for sure they are not anti-abortion. So what you do is you take your questionnaire and give it your attitude scales and give it to both groups, each person, each group. What do you expect the responses from the two groups to be? To be opposite to each other, because they believe in the opposite. If you say a question, abortion is not bad, then the other person is going to say abortion is very bad. Okay? And so So when the scores come back and you run your thing, you should get significantly different scores from the two groups. Discriminant validity. It discriminates well between two groups which differ on that particular issue. Now, that is an objective indicator. There are other ways in which validity may be measured. These are, okay, I only have, could be predictive of the future. That's it. Could be predictive of a future event. It's quite common for students to take an entrance exam before, getting into a IIT or getting into one of the colleges, or the GRE exam or the GMAT, whatever. It's quite common. But why do universities make students take the GRE exam, and those who get high GRE scores have an advantage of being selected? Why? What is it about the GRE score that makes somebody who gets a certain high band score to be admitted easily? There is something in that GRE test, that information it is giving me, that if you do well on this test, you are ready to tackle college courses and do well. That's basically what is being said. So how do they measure whether the GRE score is a valid measure of success in college? What they do is, over several years, after spending 3 to 4 years at the university, the student will graduate with a certain grade point average. And universities have the grade point averages for every student who has graduated. You can run correlation between the final GPA and GRE scores. If the two, those numbers are highly correlated, that is an indication that the content of the GRE, was a good, valid indicator of how they'll do in college, because you're comparing it with their GPA over 3 or 4 years, right? So comparing something at the present time with a future outcome. That's another objective indicator of validity. So basically then, are you measuring what you're supposed to measure? That is what validity is. And these are some tests. Is that the end? Yeah, could you load another PowerPoint? What we will do now is, in the time that we have left, go very quickly over one more item that comprises methodology before we get into data analysis. Yeah, next one. And that is sampling. And I did make a few comments about sampling. This is very, very, very important for surveys and also content analysis. This involves the selection of units for your study from which you're going to be collecting data. Often, it's very hard for us to cover everybody, time, money constraints. So we would always like to take a smaller group from the larger group. So if you're surveying the students at your university, you're not going to give a questionnaire to every student, or rather it's not necessary. you can select a smaller group. That is called sampling. That group that you select can be representative of the whole, not. Right? And so there are two kinds of sampling strategies. One is random probability sampling. And in this method, you want to make sure that the group that you select from the larger group, from the population, is representative of. In other words, it is similar to the population on the aspects that you're going to be covering in your study. So most surveys are sample surveys, random probability sample, because one of the big advantage of surveys is after all the data is collected and analyzed, you generalize the results beyond your sample. So if I've done a college-wide study on just 300 students, when actually there are 3,000 students in my college, when I'm done with the study, if I have chosen a random sample of 300, I'm going to talk about this students in this college, not the 300 students that were part of my sample. I'm generalizing it from my sample to the population, which is allowed if you selected a random probability sampling method. Okay, there are so target population is from where you select. It's also called sampling frame. You sample it. Next one, probability sampling. So the probability sampling that I said is based on probability statistics. One of the advantages of that is that it helps you determine if your sample is representative of the population. Next one. There are many ways of selecting a probability sample. The simplest is a simple random sample. From the total list from your population, everybody, let's say they're human beings, everybody gets a unique ID. And then from that group, a certain number is selected using the principle of random sampling, which works on the principle every unit gets the same chance to be selected. That's the operational rule. Every unit gets the same chance to be selected. And ultimately, we are going to select as many as we have said we will. So simple random sampling is very simple. That's what it's called, simple random sampling, right? One way to describe this is like, so you have what, 3,000 students in your college, okay? You don't do it this way, but this is how the principle behind it. Get sheets of yellow paper, okay, and the paper little size, same shape, and write down the ID number of every student, one student at a time on one little paper, roll it into a paper ball and drop it into a baseball cap. Just drop it. So at the end of the day, you'll have 3,000 paper balls. Same color, same weight, same shape. Then you have your 5-year-old come and say, just pick one. And you shuffle the whole thing and pick one. Open the thing, and there's an ID number on that. That person is selected. What did you do? Every paper ball had the same chance, theoretically, of being selected. Because you shuffled it, made sure, pick one. But this number got picked. It's like your lottery tickets, what was the probability of this first 1 out of 3,000 was the probability. Then you go for the second one. Now, 3,000 is not a big number as opposed to 300,000 or 3 million. So with small populations, I will roll that paper ball back into a ball and drop it back in the thing and shuffle it again and then select one more. And the reason is very simple, because every selection has to be 1 over 3,000. Every selection, what was that? Every unit has then same chance of being selected. If I didn't put that paper ball back, the second person will have a probability of 1 over 2,999, which is not the same. But that is what it is, how it is done. With very big populations, you don't have to replace it because the difference is so small. But these days, computers take care of that. You just feed the computer your program with all the ID numbers and give an instruction to randomly select. It'll do exactly what we are doing. That's a random sample. So simple, that is simple random sample. Next one, again, there's something called systematic sampling. Again, I don't want to get too much into it. This is slightly different from simple random sampling, but the principle is still the same. Every unit in the population has the same equal chance of being selected. You cannot violate that rule. And systematic, you do it in a slightly different way. You organize it into a list rather than putting everything into a thing. And then you have ways of random start from the list and then skip an interval and then the next one and the next one and the next one. Okay. Okay, next one. Next one, please. Systematic sampling. When you do that, if you read in your methodology book, there could be some problems, so you need better watch out. You know, if the list that you use has a certain pattern to it, then when you take an interval each time, you may be reflecting the same pattern. So the original list from which you select has to be all mixed up. Okay. But there is something called stratified sampling. Many times you cannot do simple random or systematic because both of these. Okay, what's on the next one? No, go back. Yeah. Okay, no, before I go on to that, I want to talk about stratified sample. Let's go back to the college example. 3,000 students. In the US, you know, we have students by ethnicity, Black, white, and, you know, Native Americans, like that. We have these groups of students. Let's say you're doing a study on students' perceptions and evaluations about their college satisfaction. Okay. I want to maintain, like, white students, there are Black students. In India, you could have it by religion. I don't know, but I'm just giving you an example. I want to make sure that I have now white students are in a much bigger number, you know, than the Black students. They are only about 20%. White students may be something like 70%. Okay. So if I did a simple random sample, there is the likelihood that more people will be selected from the dominant group because of the size. I don't want that. I want equal proportionate from each group. So if there are 70% of the students in the college are white, I want 70% of my sample to be white. If there are 20 in the percent in the population of blacks, I want similarly in my thing. So if you want to do that, it's better to go with a stratified sample. Before you select, group them by the group to which they belong. So then rather than all 3,000 students now, you have one group white students, one group black students, one group something else. And you have 300 students you need for your sample. What is 70% of 300? It is that many number randomly you will select from the first group. And then similarly, 20% of the sample has to be black. What is that number out of 300? Some number. Select from the second group. The nice thing about this is that you will get enough from each group so that statistical analysis may be made. One of the challenges with statistical analysis is you need to have sufficient data. If there's very little data, statistics doesn't work very well. So you need at least 20 to 25 units in each group when you compare and do statistical analysis. So if you have very small groups, like only 5, there are ways to tackle that. I'm not saying no, but so we go for larger samples, because after we have selected a sample, we are going to subdivide that, so we want to make sure. One of the, they say, for any kind of analysis, it would be great if you had at least 100 units in each group. 100. Most of the time we don't get that. So there is, if you take a statistics class, they have statistics for large samples, which is defined as equal to greater than 100. There is statistics that you should use for smaller samples, at least 50. And then there is statistics for very small numbers. So there is all special statistics, because it does make a difference. Stratified sample, again, is you make sure that you stratify according to something that is important for your study. All right. I can also stratify people by their shoe size. Everybody with shoe size 10, one group. Shoe size 8, another group. But what has shoe size got to do with my study? Right. So it has to be on some valid criterion. Can you go down? Yeah. Everything that I was been talking about, I didn't realize it's already here. Among the 4 that we are going to talk about, and this is the third, stratified sampling will produce the lowest sampling error. Remember, anytime you measure anything, you are committing error. That is a given. So we want to reduce the error to a minimum. And we're talking of sampling error. So when you stratify them, when you group them ahead of time, some of the variance that you see, you're reducing it by already putting them. And so you reduce the overall error. Some of it requires some help with statistics knowledge. Next one. And the final one is called multi-stage cluster sampling. This is something that's also all of these 3 methods we discussed till now requires a master list from which you do systematic or simple or stratify. What if master list is not available? Or, if you're doing all India, let's say, for the sake of example, you're doing a survey of all university level teachers in universities in India. Let's just imagine that. There are a lot of universities in India. and a lot of people in each faculty, in each university, and there is no master list available, you know. So then how do I select them? I want to make sure that everybody has an equal chance. So you may have to do a few things. For example, the sampling has to be done in multiple stages. That's why it's called multi-stage. Multi-stage. So you start at the stage at which a list is available, right? I'm going to keep it simple. You can actually make, I can definitely with something make a list of all the recognized universities in the country. That's not a problem. It'll take me some time. I can prepare a list. Start from there. First stage, you sample the universities. Okay, you're looking for a 40% sample. And let's say there are 100 universities in the country, example, then your sample size will be 40. That's just an example. It's a bit small actually. So same principle. Every university has an equal chance of being selected. So in the second stage, you have the selected universities list. You repeat that. Okay. Now, it may be possible for you to contact some official in every university, okay, and get a list of the faculty, the teachers in their university. It is possible. Remember, this is only for an example, okay? So now you will have to, it'll take you some time, compile a list of the faculty in these selected 40 universities. So now you have, let's say, for sake of example, there are 10 faculty in every university, and you have selected 40. So now you have a list of 400. Same thing. Now in this 400, you select your 40% sample of the faculty from that list. Well, you got it. That's what you wanted to do, right? You got it. But you had to go through 3 stages in this case. And that is called multiple stages. Sampling error is the highest for this one. Simple. Every time you sample, you make an error. You're sampling 3 times. So you're committing error 3 times. So you can reduce that. By the way, there are ways to reduce that. Before you think you can stratify the universities, you can say, take all the Northeast universities and put them in one group. You can put all the South Indian, I'm just coming up with examples. By region of the country, you can make stratify. That's one way to do that. Even better way would be the size of the university. There are some big universities and then there are some small universities. So you can stratify them by size. Big, medium, small in terms of number of students, that is. So by stratifying it, remember, stratified sampling has the lowest error. So you can reduce some of the error in that, okay? All right, what do we have next now? Yeah, so probability sampling has to be followed in surveys. Content analysis, you do the same thing, but the units will be, you know, in the case of newspaper stories, you know, so that will differ, but the methodology of selection, random, is the same. Now let me finish up with experiments. Experiments also, you have experimental group. Sometimes you have more than one experimental group. Control group, you know, how do you select? The numbers are very small for experiments. You don't, like a survey, you might have 500 people, you don't do experiments, with 500 people in, it is a much smaller group. But how do you select them? All right. Many times it's a non-probability sample. A non-probability sample is the opposite of a probability sample. In probability sample, every unit in the population has to get a same chance of being selected. In non-probability, no such rule exists. Okay, so for example, examples are available sample. I'm a teacher at my university, and I'm teaching a class of 50 students. So I'll decide to use the 50 students in my class as a sample. I didn't give all the students in the university or the college the same chance. I just selected the 40. That's an example of a non-probability sample, available sample. There is also, next one, please. Yeah, available sample, convenient sample, judgment sample. If you know something about your population, then you can use your judgment to do that. For example, we teachers, we get evaluated all the time. In US, every semester, the students at the end of the semester will have to fill out an evaluation sheet. It is done, okay? And I, the teacher, I'm teaching this class, and I want to know how good is my teaching, whether they like it, whether they like the book, and etc., etc. So I can do an example of a judgment sample. I know that to some extent, a person's response, a student's response might be in terms of what kind of students they are. There are some students who consistently get an A or a B. There are some students who will consistently fail. Okay. And I don't want to mix up the students. So I have already given two tests, and I know from the results who are the ones who get A and B, who are the average ones, and who are the ones who are failing. So I can use that judgment and do a stratified sample, just like that. But I don't give everybody equal chance. I'll go to the group of A's and B's, and I will just select. I don't give all of them the same chance. I'll do with the others until I have what I need. That's a judgment sample. Quota is very similar to that. Then there is volunteer sample, which is done a lot by media. If you agree with this, please call this 900 number. So you have to call the 900 number. You are a volunteer. And that's a volunteer sample. Or snowball sample. Sometimes for certain kinds of populations, you can't get a list. You're doing a study of the homeless. There is no list of homeless people. You don't even know sometimes, where can I find homeless people? Snowball sample is somehow your social work friend tells you he knows one person, and he will introduce you to him. So you go to that person. And then that person, you ask for names of others, and that person will give you. And this is like a snowball. When a snowball starts at the top of the mountain, it is very small. But as it rolls down the mountain, the snowball gets bigger and bigger and bigger. So you start with one person and then ask that person to refer you to others, and then keeps going until you get what you want. So sometimes that's the only way out. So these are all examples of non-probability sampling. And coming back to experiments, you do a non-probability sample. That is, you're doing this study among college students. this experiment. So make sure everybody there is a active college student. Okay, make sure they are all in this similar age group. Make sure that they represent equally females and males. You know, it's a non-property sample. Make sure. All right. So let's say you get 40 people. Next stage is important. You have to assign 20 to the experimental group and 20 to the control group. There, you have to make sure that the two groups are similar. That's when you do random sampling on that 40. If it's only two groups, you can toss a coin. Heads, you go here, tails, you go there. According to probability statistics, if you do it over and over and over again, number of times, 50% of the time you get heads, 50% of the time you get tails. So that's the whole idea of a coin toss. So you can do a coin toss to help you randomize into the two groups. There are many other ways of randomizing. The point is the two have to be similar. And you can test them in your pretest. And if the scores on your dependent variable in the pretest are similar, then yeah, you have achieved that. Okay, so that is the important one. You also have to make sure, as I said, in other ways too, the control group has to be treated in exactly the same way as the experimental group. If they get the treatment in the morning at 8 o'clock before breakfast, this group also morning at 8 o'clock before breakfast. You don't want to mix them together at any time. They shouldn't come into contact, but you match them so that there is no difference between the two groups except for the treatment. That's how we do that. Is there another one after this? Okay. No, yeah, what's the next? That's it, no? Yeah, this one gets into much detail, and this PowerPoint is available for you. You can look at it, and you may need to refer to a methodology book, but it just goes much deeper into each one of these things. Okay, let's stop at the conclusion. Some of the things I've been talking in this that I did not explain, for example, sometimes we get very heterogeneous population. Heterogeneous population is that the members of the population differ significantly among each other. The more the difference, the more the error. The more the homogeneity, less the error. Okay, it's as simple as that. And for the last few election cycles in US, on political issues, we have been dealing all the way from 2016, a highly heterogeneous population in US. United States for the last 8 years is a 50-50 nation. And if you go and look at the statistics of the presidential candidate in 2016, Hillary Clinton versus Donald Trump, and look at percent they got each, you'll notice how close each one is to 50%. And just to give you a reference to the present election, the way things are happening there, it almost feels like this present president won a huge landslide that gave him the mandate to do whatever the heck he wants to do. It seems like that, doesn't it? But do you know the numbers? Trump got 49.7% votes. Kamala Harris got 48.5. The difference dividing them is less than 2%. Right? But winner is a winner. George W. Bush, 5 years ago, won by a few hundred votes over Albert Gore. So his was even smaller, you know. But that's how it is. So when the population gets close to 50-50, that is the highest level of heterogeneity. Okay. You can't have more variance than that, 50-50. After that, variance starts reducing because after that it will be what? 49-51. 45-55. You see, it gets, and then finally you're going to get to what? 199. So it gets more and more. That is why pollsters had such a hard time in 2016, and most of them were consistently wrong in their projections in 2016. It happened in 2020 also, but not as much as 2016, because the pollsters learned what the problems were and they did a better job in terms of correcting for that. And this election, you really have to give a clap to the pollsters because they were dealing with exactly 50-50 and coming up with projections can be really, really hard, selection of samples like that. So you will see in the thing, population heterogeneity can make a huge difference. All right. Okay, so with that, we are going to go on to question answers, right? Yeah. You. How can we differentiate both? I really don't know what really the definition of thematic analysis is. If it is something that is, doing research on different themes of the same thing. One of the things with content analysis is it is being used both by quantitative researchers and qualitative researchers. So content analysis is a valid methodology even in qualitative analysis. They may not call it content analysis, they call it by other names. And thematic analysis is a much more of a qualitative technique than a quantitative, okay? Because they do examination of content, in history, and kinds of other fields. So I would imagine, but it's basically selection of content according to some criterion. What we have used here is a random selection according to content. Thematic could be something that categories that are drawn by the researcher, and then you look for those kinds of recurring themes in what you look at. Operational definitions in qualitative. Operational definition. Well, you have to at least identify exactly what you're going to be collecting information on. So at that level, yes. But remember, in a quantitative analysis, I kept on talking about the empirical referent to that concept. Empirical referent. Empirical means something you can observe and count, right? Which in qualitative also you have to do. Qualitative analysis also you have to go out and do long interviews and other things with people and collect information. You still have to go out and collect data. So qualitative research, as opposed to what some people think, is still empirical, except that you don't follow the postulates of positivism that we talked about, okay? And you give more flexibility for reflection and explanation, so qualitative studies are what we call as thick description. Thick description, that is what they are meant to collect as much of qualitative information as possible. So to answer your question, operational definition is something that is used in quantitative kinds of study. You don't call it as operational definition. You call it by something else, and it doesn't have a quantitative empirical referent. That's the big difference. Because in quantitative studies, the empirical referent has to be a number on some scale that is reliable and valid. In qualitative, it's not a number. And you don't expect, things to be exactly the same. Each person might give different accounts when people tell you their stories, and so on and so forth. So that's not a term that is common among qualitative researchers. Yeah.
Can we decide whether probability sample is good, non-probability sample is good, based on what perspective we have to decide the question? Oh.
Okay, that's fine.
Choose the respondent here.
I would refrain from using the word good and bad here, and what is proper and what is improper, what is appropriate, and what is not appropriate. There's nothing like good or bad, because everything depends on what is your study about? What is the historical context? What is the social context? Okay. So certain kinds of studies absolutely require random sampling. All the government information on health information, you have to choose a random sample, because when you generalize the results, it has to be representative of the population. So if you require that, the ability to generalize the results from your data to the entire population, then you have to choose a probability sampling method. But there are many situations where it is not necessary to generalize or not possible to generalize. In which situations you can do a non-probability sample. Okay. For example, I kept on talking about the questionnaire that you prepare. Make sure you pre-test the questionnaire before you get it ready. When you pre-test the questionnaire, with whom are you going to pre-test that questionnaire? On the people who are going to be part of your study, your college students. So you don't have to select a random sample. As long as you get a bunch of college students from your college, that's good enough to pre-test the questionnaire. Understand? So you would, make sure that you have males and females, a junior class, senior class, you make sure. You don't have to compile a list and make sure everybody gets an equal chance. Or another situation. You're a journalist and you happen to take Dr. Melkote's class, okay? But you're a journalist and you have to report on a natural disaster that took place. Some area, there is flash floods and whatever, and people's houses and huts have been, water. And as a journalist, you have to go and interview. I mean, it looks good, no, for TV, putting a microphone in somebody's mouth. And so you need to identify people who are been affected by that. And then you put the mic in front of them so that they can talk. How are you going to select the people? You reach the village where the floods have come. Now, who do I go? Who do I go and put my mic in front of them? Anybody you can get as quickly as possible, as long as they are from that village and as long as they are part of what you're looking at. You're not going to say, wait a minute, Melkote said random probability sampling, so let me make a list of all the people and then from them select a random sample. Doesn't make sense. So depending on the social context, depending on what you want for your study, you go with random sampling or non-random sampling. It's impossible to do random sampling if your study is among homeless people or drug addicts, or certain people who have served time in the jail and have been released, and you can't get them. And even when you get them, it could be risky for them. Okay, so non-random sampling will work very well. So there's nothing like good here. It is, what is it you want to do? It's all dependent on that. Yeah. Yes.
Take this. I'll take this. I'll take this. You come.
So my question is from experimental research. When we are planning the intervention, pre-test and post-test, in between when we are making the intervention, do we have some standards to follow, or is it completely the autonomy of researcher to decide that what intervention is he or she going to give to the groups.
Because remember that experiment is where you're trying to find out the cause. And so you need to be very, very certain that you are not creating any kind of bias. So it has to be, uniformity in the treatment, and everything. For example, if you are part of the intervention, then you are supposed to treat everybody in exactly the same way. Even unconsciously, you cannot bias. For example, that especially during medical trials, one group gets the actual medicine, the other group doesn't get the medicine, it just gets a dummy, a sugar pill. Yeah, placebo. And so, but the pills themselves look exactly the same. There's just a code at the back that tells you which is which. But somehow you're one of the interventionists there, you might use that knowledge, say, oh, this person is not actually getting the real drug. And so your communication with them may be slightly different from the other one, or you might be a little more sympathetic to them. I don't know. You might do that, will bias. So there is something called double blind that is done in intervention. Double blind is where the intervention person also does not know who is getting treatment and who is not getting treatment. That way, you will behave and in exactly the same way with everybody. So to answer your question, it is not left to the individual, whatever of the person.
So adding to it, you have talked about violence today. So just one question came to mind, that there is plethora of media content, right? That is talking about violence. When we are measuring it, how do we as researchers decide that what media content we are going to expose the group to?
The media content has already been selected. You don't get to, so all you do is you code it. Okay. So all you have is a set of instructions on how to identify what you are looking for in your content. You don't get that has already been done for you. And so that flexibility is not there. And you just follow the operational definitions of exactly what, and you do your job as faithfully and accurately as is given. All the other decisions are left to the head of the unit, the organizer who's, doing that, and they take care of all of that. Okay, thank you very much. And so we'll see you again next week when we move on to ethics, and later we'll actually have some people come here and work with SPSS and show you some of the analysis